Hello students, in the previous video we have derived the relation energy of electron in the nth orbit. So here it is the formula. En is equal to minus me, it is a suffix, me z square e raised to 4. What is me? Me is mass of electron. Z it is the atomic number. E raised to 4, that is charge on electron raised to 4 upon 8 epsilon square n square h square, and this can be written En is equal to minus 13.6 electron volt z square upon n square, because the remaining term except z square upon n square is a constant term, and that is written in the form 13.6 electron volt. This energy is negative. Z square, that is Z depends on the element or the atom, but for hydrogen atom what is the value of Z? Z is equal to 1. So you can write En is equal to minus 13.6 electron volt upon n square. Energy of electron in the hydrogen atom in the nth orbit, it is given by this equation, minus 13.6 electron volt upon n square. This energy is in electron volt. Suppose you want to convert it into joule, then you have to multiply it by 1.6 10 raised to minus 19 joule. So depending on n, you can find out energy of electron in the definite orbit. So if n is equal to 1, then put here 1 square. If n is equal to 2, then put here 2 square, and so on. So you will get the energy of electron in the different orbits. As n increases, En also increases. Suppose in the first orbit there is an electron, it has energy minus 13.6 electron volt upon 1 square, that is 1. If the electron is in the second orbit, then you have to divide it by 2 square, that is upon 4, and this becomes minus 3.4 electron volt. So minus 13.6 electron volt and minus 3.4 electron volt. Here E2 is greater than E1. This we have seen in the previous video. Suppose you want to find out energy of electron in very outermost orbit. So you can take here n is equal to outermost orbit, n is equal to infinity. Then what you will get? E infinity is almost equal to 0, because n square infinity square, again it is infinity, and E infinity is equal to 0. So this is a highest energy. This is highest energy. When the electron goes into outer orbit, its energy increases. So outer orbit energy is greater than inner orbit energy. So you can write here outer orbit, if you take this orbit as n and inner orbit is suppose m, then En is greater than Em. Now from these energies, the question is asked, draw energy level diagram. Means suppose in case of hydrogen atom, if the electron is in the first orbit, positively charged nucleus, and first orbit there is an electron. In hydrogen atom, this E1 is minus 13.6 electron volt. If suppose energy is supplied to such electron or such atom, electron absorb the energy, and depending upon the energy, absorb energy, it goes into outer orbit. And when it goes into outer orbit, then suppose it goes into second orbit, then this electron is not stable and it comes into first orbit again by emitting radiations, and these radiations appeared as wavelength or spectral lines in the spectrum, hydrogen spectrum. So what kind of radiations are emitted when there is a transition of electron from outer orbit to inner orbit, depending on which is the outer orbit and which is inner orbit. which is outer orbit and which is inner orbit. Then this radiation, wavelength of these radiations can be determined by the formula which is also discussed in the previous video. The formula is also discussed in the previous video, and that formula you have to derive, and the formula is called Redworks formula. So here the radiations are from second orbit to first orbit, or may third orbit to first orbit, or may from fourth to first. Then there is a some kind of radiations are emitted by the electron during this transition. So the energy level diagram contains the transition of electron from outer level or outer orbit to inner orbit, and what kind of radiations are emitted. Those radiations are grouped and name of the scientist. So these energy level diagrams, these energy levels are asked in the exam. एनर्जी लेवल डायग्राम ही एक्झाम मध्ये विचारली जाते. 2 मार्क्स साठी ही डायग्राम विचारली जाते बोर्ड एक्झाम मध्ये. So we'll discuss the energy level diagram. So how the energy levels are drawn. So here we will discuss one more point. When the electron is in the first orbit, then this is the energy. E1 is equal to minus 13.6 electron volt. It is a minimum energy because this is the first orbit. So when energy of the outer orbit is greater than that of inner orbit, so obviously this E1 is minimum energy. And this energy is called, or the electron is called, it is in the ground state of the atom. Electron is in the first orbit. Minimum energy level is the first orbit level. So when electron is in that orbit, then it is said to be in a ground state of atom. Ground state means lowest energy level in the atom. Lowest energy level in the atom, that is a ground state of electron. So hydrogen, in hydrogen atom, when the electron is in the first orbit, then we can say that electron is in the ground state. Suppose the electron absorbs some energy and goes into the next orbit, outer orbit, then the electron is in an excited state, not in a ground state, because the hydrogen atom structure is electron in the first orbit. So first orbit is called ground state level. So electron when goes to the outer orbit, then that orbit, when electron is present in that orbit, the electron is said to be in an excited state. But orbits having higher values of n and therefore higher values of energy, higher values of n is suppose 1 first orbit, second orbit n is equal to 2. So energy increases as the number n increases. So these are called excited state of atom. Now here we draw the energy level diagram. Energy levels of hydrogen atom. Specifically it is for hydrogen atom. This is a common question in board exam. Energy level diagram, how you can draw the energy levels. Energy levels, draw the lines one above the other by space between the two lines goes on decreasing. These are the energy levels because energy difference is, first it is minus 13.6, then it is minus 3.4, then 1.51, then 0.85. How these are defined? The usual formula, minus 13.6 electron volt upon n square. So put n is equal to 2, you will get E2, n is equal to 3, you will get E3 and then continue, and the last is E equal to 0 when n is equal to infinity. As n increases, energy also increases, and E0 is the highest energy level. Now if the electron absorbs some energy and goes to the second orbit, suppose this is a electron in the first orbit, positively charged nucleus, and electron, if we provide the energy to such atom and electron absorbs some energy and goes to the outer orbit, suppose the outer orbit is number 2, this is the inner orbit, n is equal to 1, then the electron is now in the excited state and it comes back into its previous stable state by emitting radiation. So there is a transition of electron from n equal to 2 to n equal to 1. This we can show here in the energy level diagram as like this by drawing a line. By drawing a line from n equal to 2 to n equal to 1. So here the kind of radiation. Here there is a radiation emitted by electron, electromagnetic radiation. And what is the wavelength of this radiation? We can determine by using the formula. Suppose the electron absorbs again more energy and it suppose goes into the next orbit, n is equal to 3. Then from n is equal to 3, there is a transition of electron from 3 to 1. So you can show that from 3 to 1 also. Electron goes into outer orbit by absorbing energy and return to the previous orbit by emitting radiations. So any orbit, if the electron goes, it comes into the previous orbit, n is equal to 1. So here you can show that n is equal to 3, transition n is equal to 1, inner orbit. So n is equal to 4, again outer orbit to inner orbit. So next is n is equal to 5 to 1. So you can show this as n is equal to last. So in between lines are not shown. N is equal to infinity to n is equal to 1. So this is the transition of electron from outer orbit to inner orbit. So there may be number of wavelengths, number of frequencies, number of wavelengths. So these are the wavelengths emitted by transition of electron when there is a transition of outer orbit to inner orbit. Here inner orbit is fixed. Inner orbit is n is equal to 1 and outer orbit goes on changing. So these type of transitions, these type of radiations are studied by scientist Lyman. So the name of this series is Lyman series. These kind of radiations having low wavelength but high frequencies. So the Lyman series lies in ultraviolet region. The next scientist Balmer, he has studied that radiations coming from electron when there is a transition from outer orbit to second inner orbit. If the electron is in the second orbit and it goes to the outer orbit and come back into the second orbit, then there is a radiation of definite frequencies. So here n is equal to 2 and n is equal to 3. This is a transition. So you can show the one more transition. N is equal to 4 to 2, 5 to 2, then continue this, and last is n is equal to infinity to n is equal to 2, outer orbit to inner orbit. Here again the inner orbit number is fixed. So this is again one more series, but this series lies in visible region and studied by Balmer. So it is a Balmer series, visible region. Then there are number of series. Take the inner orbit fixed and outer orbit continuously changing. So n is equal to 3 inner orbit. The transition of electron from outer orbit to inner orbit having principal quantum number 3. So 5 to 3, then again next orbit to 3, then last orbit n equal to infinity to n equal to 3. This is one more kind of series, Paschen series, infrared region. So this series lies in an infrared region. Next one, n is equal to 4. Again there is a series, new series studied by bracket series, studied by bracket, and next is studied by fund. So the name of the series is fund series. So these lies near infrared and far infrared region. Bracket series, fund series. So this is energy level diagram. This energy level is diagram asks for 2 marks. So here you have to write energies, and here principal quantum number, that is number of orbit, and show the transition from outer orbit to fixed inner orbit. You will get the series of wavelength and name this series, so you will get the full marks.